Okay. We are redoing session number 3, and we're just going to be starting on cutting operations. So we'll just be doing our facing operations or contouring and pocketing, as well as simulating our toolpaths to see what our tools will actually do. Okay. Oh, I forgot. I need to share my screen. Okay. Yep. So, okay. So this is where you can create all of your cutting operations. This is the solid mode traditional toolbar, and you can look at all these different buttons where it's facing first, and then pocketing, then contouring. And there's one over here that I haven't used a lot, and then right after it is the drill/tap operation. And pretty much when you want to create a cutting operation, you always click on the chain first that you want to assign the operation to, and then click on which operation. So we can go to this. So these are all your chains over here, and then you click on this button over here, solid mode traditional dash solid mode production, and you'll get all of these different cutting operations. We're going to start with our facing operation. So to do that, we're going to select our outline of stock chain, which is this rectangle one. And once you click on it, the chain should turn grayish. And that's how you know you selected the right one. After you select that one, you go ahead and press facing right over here. And then something on the left should pop up. So whenever you start creating a cutting operation, just go ahead and click General, this tab over here, and then select your tool. And that selection it's called tool selection. So first, we're just going to use the face mill. And now we got to find our feet and speeds. And if you remembered from session number 2, you can find them in MFE Labs. So this website over here, you can just go to the drop down where it says information for students, and the last one is called feet and speeds. Face mill, we're just gonna click on this link right here, and it's gonna tell us the feet and speeds that we want to use, or at least the suggested ones. So our speed, we're going to use the starting speed at 42.52 feet per minute. And then our feet per tooth, we're going to use 0.003 of an inch. Remember, it says the unit here. So cutting speed can either be in the units of RPM or SFM. Since it's giving us an SFM, you can put it right here. If you look at the feet and speeds over here, it says RPM, SPM. SPM and SFM are the same thing. This first box is if you know the RPM, and the second box if you know the surface feet per minute. So we know the surface feet per minute, which is 42.52. So we're going to put it in the second box. And then we know that feet per tooth, which is going to be the second one, because there's XY feed rate per minute and comma per tooth. So we want to use the one that says PT per tooth. And that's going to be 0.003. And that's going to be the same thing for the Z. And that is our feeds and speeds for our face mill. So I'm just going to keep going, but if you want me to stop, just let me know. Okay. So we're going to go to our strategy tab. There's always different strategies you can use. The current one is zigzag, and that's the one is pretty standard for facing, and I wouldn't mess with that one too much. Usually for facing, don't mess with T's. Facing is a fairly simple cutting operation, so there's no need to make it more complex than it needs to be. Okay, and then right here where it says step over diameter, step over percentage of diameter, that's going to be your radial depth of cut. That is what you call your AE right here. So if you refer to this diagram, your radial distance is AE. And they want you to assign your radial depth of cut to be 1.591. It's pretty much that, so it's okay to leave it as 1.5. And don't worry about a hangover. You can just leave it like that. Okay, and now the next and most important thing is depth. So simply, starting depth is essentially where the tool starts, and total depth is where it ends. So total depth is not like an absolute depth, like how much it should travel. It's the exact position it travels to. So it's a little misleading. Um, and an incremental depth is your axial depth cut. So essentially, how deep your tool goes for every pass, how deep axially. Um, so those are all. So the incremental depth cut is something that's got documented. So you just use AP, your axial depth cut, and that's going to be 0.29. Something about your depth of cuts for both axial and radial, those are very much suggestions, and it's very much okay to lower them. Because if you lower them, you're taking more time, but you're just putting a lot less stress on your tools, and that's always okay. You never want to go up unless you've tested that tool and you know that it can handle higher depth of cuts. But sticking with these numbers is a very good thing to do because they've been tested and these are what is recommended by the manufacturer of the tool. So we'll just stick with 0.29. And then for starting depth, you can always see here for starting depth and total depth, there's this mouse button. So you can click on that and you can click on a point on where it should start. So for starting depth, the stock starts at the origin. So you actually just want to just click on the origin right there. And then it will put in a number. It's not too easy to follow what this means because it's giving you a negative number. And I don't know why it does that, but it does that. And I'm not really worried about it too much. And then for total depth, you click on it, and you just want to click on any point that's on the Z level of the top face. So this point is perfectly fine right here. And so you can probably notice that total depth didn't change. That's because starting depth is automatically set to the highest Z value of that chain, and then total depth is assigned to the lowest Z value of the chain. So you remembered starting depth and total depth were set to 0 automatically. That's because the lowest and highest point are the same. So they're going to be equal. But our total depth is the lowest point, and that's where we actually want to go. But our starting depth is above the chain, so we have to indicate the value that we want it to start at. So we have 0.29 and negative 0.5. And yeah, that is what we're going to do for strategy. And then usually there's not too much for links. We're not going to really cover much about the links tab. So we're just going to go ahead and press OK. Yeah, so that is what you should see. Red solid lines indicate a line where the tool is actively rotating and therefore cutting into the material. But you can also see there are dashed red lines, and that is what we call when it's rapiding. So when the tool is rapiding, it means that it's moving in the X, Y, and Z direction, but it's not spinning. So it's just traveling from one point to another without cutting any material. So that's a good way to see if like it's cutting in areas that it should be, which it is. So now we can just go ahead and simulate it. So the simulation button is this green one on the toolbar right here. And if we click on it, you'll get this toolbar. And before we run any simulations, we want to change the settings. So let's go to simulation parameters, this little page right here, and then change. Yeah, make sure your collision detection is in full. Otherwise, when you simulate, you won't know if anything is crashing. But if you have your collision detection in full, it will tell you if something has crashed. You just press OK. Pretty self-explanatory. Press the play button to play, press the stop button to stop. So if I press it, it's pretty fast. If you want to change the speed, there's this sliding bar. The right is faster, left is slower, so you can mess with that. to adjust the speed of the simulation. And you press play. Now, that looks good. Is anyone having any issues so far? Okay, that's good. Another important thing to do when you're in a simulation is check for your tolerances. And you can use this button called comparison, which is right here. It's like a slanted part with some colorful rainbows on it. And you click on it. Each color has a different tolerance. So if it's green, that means it's within 0.02 of an inch of the part, and other colors have different tolerances. So if you click on the button right next to the comparison button called comparison dialog, you can see the color key, and anything you see is green, it's less than 2,000. And you can change the tolerance if you want. But since you see it's blue, that means it's more than 0.008 of an inch away from the part. But that's okay because we know we haven't cut there. But if you, let's say you faced it and it's not green, that means something with your depths are probably wrong, and then you didn't go to how far that you needed to. But since we see green, that means we're good so far. Okay. Stop your simulation, just press the stop button, and then it'll show you your toolbar again. Okay. So we just did facing. That was probably an easier one. Okay. Now we're gonna go into the pocket in the middle, which is this one. So we can go ahead and click on the middle pocket chain, and you'll see that the chain is now gray in the middle. And then if you go to solid mill traditional, solid mill production, you'll click on the second cutting operation called pocketing. Yeah. I think we're going to use a 3/8 inch end. Let's see. Yep. Okay. So always go to General tab first. Select your rough tool ID. That's going to be your end mill 3/8. And for pocketing, you're going to put in your feeds and speeds in a different tab, so you don't have to worry about it. Okay, so next is the strategy tab.
I have a question.
Yep.
How did you get out of the simulation?
You have to press the stop button.
Got it.
Yeah. Okay, I'll give you like 30 seconds to catch up.
Sorry, wait. So could you go back real quick? So you clicked on what to get to where?
So
Sorry.
middle pocket. So that's the
Yep.
pocket that we want to machine. Then click on pocketing, which is first the solid mode traditional toolbar, and then pocketing.
I don't think it's appearing for me.
None of these buttons are appearing?
Nah, none of those are.
Did you click on solid mill traditional first? And right here.
Switch to solid mill. And I click on switch to solid mill. But the toolbar.
No, not switched. Wait, you should already be in solid mill. Do you not see this toolbar?
I see that toolbar there. Is that where that is? Okay.
Yeah, solid mill traditional dash solid mill production.
Got it.
Do you see pocketing now?
Okay. Yep, now I get it.
Perfect. Okay.
Okay, thank you.
Of course. And then click on pocketing. Assign your tool, endmill 3/8. That's the tool we're going to be using for this operation. And then we're going to go to strategy. I think for tool motion pattern, it's definitely more important when you're doing like pocketing, especially pocketing and in some cases contouring, because it can be important of like which directions you're using. And typically for pocketing, I think it's pretty standard for people to use concentric out. I don't know why, but I pretty much stuck to that, and it's worked pretty well. And then there's one called profit milling, which I believe it optimizes a tool path to have the lowest radial depth cut as possible. So it will take longer, but it will try to find a way to make sure it keeps those depth cuts as low as possible. But we're not too worried. So we can just go ahead and leave it as concentric out, and everything is fine. And then, like I said before, total depth will be automatically set to the lowest point of the chain, which is where we want to go to, and the highest point will be set to starting depth. So those two values are different, and they're exactly what we want them to be. So if you want to check, you can click on starting depth and click on this high point, and it won't change. It'll stay at negative 1.6. And for some reason, the incremental depth is already set there. But if you would like to confirm, you can go to MFE Labs, go to non-ferrous end mills, 3/8 end mill, and their incremental depth is 0.375. So that may just have been set by one of the Washburn Labs people in their template, which is pretty useful. Let's see, what's in the pocket? Okay, so the pocket tab, which we'll use in something else today, but we're gonna move on since we don't need it. We're just gonna go to roughing tab, and this is where it is gonna ask us to put our speeds and feeds. So if you remembered, for when you're using end mills, you're gonna want to set your RPM to whatever the max RPM of the machine is. So yeah, so mini mill 6,000 RPM, VM2 12,000 RPM, and super mini mill 15,000. So let's just say we're using the VM2. We'll say that we're using the VM2 for all of the different cutting operations today. So we're just going to put in 12,000 for our RPM. Notice how last time our base mill, the Excel sheet gave us the surface feet per minute, the SPM, but this time we're giving it the RPM for the end mill. So that's just something to note. But you only need to put in one because it automatically calculates the second. Then we need to find our Z feed rate, which is here. It is 0.003 in the X and Y per tooth, and then 0.0006 for the Z per tooth. And I think that is it. Okay. Okay. And then there's cutting strategy. So the two cutting strategies are climb and conventional. Typically for CNC, you're going to want to use climb. What climb is you're cutting in such a fashion that the tool is being pulled into the part. But conventional is when you're cutting and the tool is being pushed away from the part. And that's something you want to use when you're using like a manual lathe or a manual mill, because when the tool is being pushed away from the part, you have more control and you're less likely to cut into the part where you don't want to. But it's okay to use climb milling because the CNCs won't really have an issue with that. So leaving it as climb is perfectly fine. And then we have our step over diameter, which is our radial depth of cut. And that is our AE, step over AE. That's going to be 0.09375. And just so you know, all of these radial depth of cuts are set to 25% of the diameter. So you can just go ahead and change to 25%. And 25% is like pretty standard. It's good. It's not too harsh on the tools, but it doesn't take forever. So it's okay. We can use that.
Do you have one extra zero in your Z feed rate?
It is 0.006.
0.000.
Yeah, it's
It looks
6/10 of a thousandth. It's this number.
Yes, then go back. 1, 2,
Oh,
3,
I haven't.
4.
Oopsie, my bad.
No
You
worries.
were right. I had
You're
enough space
chilling.
here. Okay, thank you. Otherwise, everything's good.
That I can see, yeah?
Okay, perfect. And then let's see what happens when we press OK. Oop. And now we have another two path. I mean, that looks good to me. Maybe. I guess you can only see if you run it. So let's do that. Good to also, when you run simulations, make sure nothing is highlighted in here. Otherwise, like let's say you had this highlighted or like this, it will just simulate this pocketing operation. So just make sure you click out of it and then simulate. So press the green button and then press play. And then I was doing a little cutting things. You'll soon realize that there is a problem. Just wait a second. Boom. Okay. So what happened is that the tool holder has hit the part, and when there's any sort of crash, it's just gonna blink red. The easy way to fix this is just put in a longer end mill. Yeah, and we can do that. We can just change it in the Esprit file. So if you go to Tools, right here, and then double click on end mill 3/8 3 end mill, and then go to Cutter right here. The last option gives you the lets you change the tool length. So you can change it to like 2.5 and you should be able to clear it. And you press OK. And then you just run it again and see what happens. Ooh. Perfect. Does everyone have this so far?
My simulation looks kind of whack, I'm not gonna lie.
Is the end product this though?
No, it's not displaying the raw stock. It's just showing the lines of.
Oh, okay. I forgot to show you that. So in a simulation, there's two buttons, one called stock visibility and one called target. So you can toggle them off and on.
Got it.
Until
Cool.
yeah.
Now,
So yeah, usually it's good to have both stock and target visibility on, so you just know like what it's cutting around if it's cutting into the stock. But yeah, I
sweet,
have both
thanks.
it on. Yeah, and you guys had no issue changing the length of the tools. Okay. Um. So now that you finished this, you can probably see that there is a problem. There is a good amount of stock that has not been cut. And this is because the end mills are circular and there's no way they'll be able to get into this sharp corner. And that is just a design flaw for the part and not something can be really easily fixed by the manufacturer. We could go through it again with a smaller end mill, but there's no way you can get all of that because just like you would need an infinitely small end mill and that was impossible. And that is just a design flaw. So something to take note of is when you're like designing something, you want to avoid sharp corners that are inside the part. It's okay to have sharp corners on the outside because end mill will just follow it, but anything on the inside, the end mill would not be able to do if it's a sharp corner. And that's why it's always a good practice to add fillets to your inside corners. That's why all this corner and this corner were able to be machined perfectly without any issues. Yeah. And you also see that there is a problem with this right here, this bottom outline, there is still stock there. And that's because end mills aren't like, they don't have perfect 90-degree corners. They're curved, so you will never be able to machine this. And that's like not something you can really fix, just something you should take note of. And then if you click on comparison, you can see how off everything is. So all these things, these blue areas are more than 8,000th of an inch away from the part. This is not, you can't fix this, but this is a design flaw which can be fixed. Yeah, just something that's good to know. And then we're gonna move on to the next thing. Yeah. Okay. Now we're gonna contour. So before you follow me do anything, I'm gonna show you what you would think you would want to do to contour, and then you're gonna see very quickly why that is not the right way to do it. Okay, so for now, just watch and don't follow because, I mean, you could follow, but I don't recommend it. Okay, so we're gonna click on outer profile, which gives us a chain that gives us the geometry of the outside. And then so instinctively you would think, okay, go to solid mode traditional and then click on contouring because, you know, we want to contour the part, so it makes sense to use a contouring operation. So let's say I'm just gonna use the 1/2 inch end mill. I'm not gonna fill out the feet and speeds because I know it's not gonna work, and it'll still simulate it without any feet and speeds, and it won't give you a problem with that. We're gonna start incremental depth 0.5 is fine. Yeah, whatever, this is fine. Okay. Wait, I think, or there, I'm missing radial depth cut. I'm looking for that. Um, okay, whatever. First, okay. So let's run it, see what happens. Okay. So other than the fact that the tool is too short, which is something we can't fix, there's these corner areas that it can't cut. That's just because contouring operations, it just cuts around the side once and does mini axial passes, but doesn't do any radial multiple passes. So sometimes that's fine. And once you cut to the bottom, it'll just throw the stock, like it'll just fling it to the side, which honestly, if just that part is small enough, it won't do any damage to the machine or the tool. But it's an improper way of doing it. Plus, if it gets too big, it can chip the tool and potentially rip through the machine. But I feel like something like this that's quite small, it's perfectly fine to throw it. I don't think the Washburn staff will give you any issues with it either. But I guess it's just not the right way of doing it. And so I'll show you the right way of doing it. But first, I'm going to change the length of the tool, which I suggest that you follow me as I do it. So we're just going to go to the toolbar, then double click on end mill, 1/2 inch end mill, go to cutter, and switch tool length to, let's do the 4 inches, and press OK. And then I'm just going to run it again so you see it. See the final product. Yeah, so it just won't be able to cut these areas, but I'm going to show you how you'll be able to do that. Okay, so I'm going to delete my contouring operation. So now I would suggest that you follow along. Also, before I start, so essentially what the takeaway is, if the stock profile is significantly larger than the part, then you don't want to use the contouring operation. You're going to actually use a pocketing operation, which I'll show you. But if the stock is only slightly larger, and you can cut it in one pass, you can cut the contouring operation in one pass, then using the contouring operation is perfectly fine. But in our case, there's a lot of room on the sides of it, which the end mill won't be able to cut some of the corners. So we're going to take a different approach. So yeah, we're going to be using half-inch end mill, like I said before, but instead of using the contouring operation, we're going to use a pocketing operation. Okay, so you can go ahead and click outer profile. No, sorry, outline of stock. So the reason why we're going to do that is because remember when we did pocketing? What pocketing does, it cuts all the material inside of a chain. And that's essentially what we want to do. We want to cut all the material that's over here inside of this area, but we don't want it to get into the part. So first, we're just going to go to click on outline of stock, click on solid mill traditional, then pocketing. Yeah, so go to general, select half-inch end mill for our tool, and for strategy, we'll leave it as concentric out, and then our total depth, we're going to click on this mouse, and then we're going to click on the most bottom part of the part, because that's how far we want it to cut down to. So you can zoom in and then click on this corner, it's probably fine. And then it'll change to 2.5. Don't be, it's not really important what the number is. As long as you know that you're clicking on the right point, you'll be fine. And the starting point is 0, but it's fine to leave as 0 because the highest point that we want to start at is at the highest point of the chain. So I can just demonstrate, you click on the chain right here, it stays at point, it stays at 0. And then we're going to leave our incremental depth as 0.5. It's perfectly fine. And that is all you need to do for in the strategy tab. Select your motion pattern, total depth, starting depth, and incremental depth. Yeah. Then we're going to go to roughing. We're going to skip the pocketing tab for now. We're going to go back to it. We're going to be roughing. We're going to now assign our feet and speeds. So if you remember the RPM max of whatever the machine is. So we're going to set it as 12,000 RPM because that is the max RPM for a VM2. And then we got to find what our XY feed rate and Z feed rate. And we know we can find that from the MFE labs. So row 25, that is our half-inch end mill. Our X feed rate is 0.005 inches per tooth. And then our Z feed rate is 0.001. So 5 thousandths and 1 thousandths. Those are XY feed rate and Z feed rate. And then for our step over percentage of diameter, just go ahead and set it to 25%. That is our radial depth cut. Okay. So don't press OK yet, but I'm going to do so you can see what happens. So essentially what it's going to do is cut all of the material inside of this box, which isn't what we want. So you can tell because it's cutting here and we don't want that. But what you can do, you go back, if you in the pocketing, click on the pocket tab, then you can assign island features. So island features are essentially chains inside of another chain that you want to avoid. So we're going to cut inside of the outer stock profile chain, but for our island chain, we're going to assign that as our outer profile. So it's going to cut within this rectangle, but it's going to avoid all of this right here. So what is it? So yeah, I'm going to cut all of this extra material, and it's going to stay away from this inside. So click on island features, then click on one of the lines of the outside profile. Oh, that's not what I wanted. Yeah, and then if you get like outer profile and the chain now turns green, which is a good indication that you're doing it right if you get green. and you press OK. Yeah. Anyone having any issues so far? You should get something like this. Okay, that's good. I'm glad that you're not having issues. So as you can see, it's staying on the outside and it's not going into the inside. So you can go ahead and simulate it. We are not there yet. Oh, what I did was I had pocketing highlighted, so it just went to start pocketing, which is not what we want. So make sure you're not clicking on any of this and then press play. Okay, so not there yet. We're getting close. So is everyone seeing something similar to this, where not everything has been cut? Okay, so let me go back to the PowerPoint. I think I have some slides on it. No. Okay, yeah, we're on this slide now. So there's something important to note when you're using any sort of milling operation in Esprit. This is a feature that only Esprit has, and it's quite dumb, but you'll see why. So essentially, the reason why it's not able to cut this side and the other side and everything else is because, remember, when we're assigning as a pocketing operation, it's not going to go outside of this rectangle. It will never move outside of the rectangle because that's essentially what pocketing means. You stay with inside and you cut everything inside. So that's why it wasn't able to cut this side, because if it were to cut it, it would have to poke outside of the rectangle, and that it's just not. It's told not to do that. So we have to tell it and allow it to go outside of the rectangle. So like telling it that it's okay to break the rules sometimes. So we go to outline of stock, and then you get this properties window over here. You can just go ahead and expand it a little bit. If you click on the plus sign for sub element, and then you'll see segment and attributes, and then you want to click on the plus sign next to attributes. So, and this is what open edge. So automatically, all of your segments in every chain is set to open edge false, which means that you're not allowed to pass that edge, that chain, if it's not allowed to. But we want it to be able to. So you can see if you click on sub elements, you see 1:5, and you can switch through all the different sub elements. What you want to do is click on false and then switch it to true. And you want to do that for all of the sub elements. That way, you're essentially allowing the toolpaths to go outside of the chain, which is sort of breaking the rules. Yeah, so sub element, then go to attributes, and you'll get the option to change if your sub element is open edge or not. And we want it to open edge true so that it's able to move outside of the chain. Yeah, right here. So once you have that done, it's not going to automatically change the toolpath, which is quite dumb. We have to essentially tell it, hey, look back at the chain. Something has changed. Please rethink about the toolpath. And how we do it is right-click the pocketing operation that we just made, go to machining, and then rebuild. Rebuild essentially tells it to reconsider the chain that it's assigned to, and if there's any changes to the chain, it will reevaluate the toolpath and make it again. And that is how it should look. That is our new toolpath, which looks pretty much, I guess, I mean, if you've done any machining, this is exactly how it should look like. It goes around a couple times, and it should never go inside the part. You go ahead and simulate it. I guess it's starting to come together. Cool. Yeah, that looks the way we want it to. Let's see what time it is. Does everyone have this right now? I think that this step was probably definitely the hardest one. It's just the most involved, a lot of different steps in this big one. So okay, I'm gonna assume that we all have this so far, which I'm very glad. Um, Something you might have noticed is that there is some stock, and that's just because of the corner radius of the end mill. If you want to get rid of it, you can go ahead and add like 5 thousandths of an inch or like 10 thousandths of an inch to your depth, so it can just go past all the way down. But for our purposes, it's not too important. We're just gonna leave it like that, and you can go click in the comparison button and see that a lot more green, which means that we are getting closer to what we want it to look like. Green is good. Okay. Next, we're going to do the side pocket. Would you guys be interested in taking 5 minutes and trying to do on your own? Or would you rather watch me do it?
I don't personally care, but I don't know if other people have opinions.
Okay, I'm gonna try to do it. I don't think we have an incredible amount of time, so let's just keep going. It's pretty much repetitive, especially because this is a pocket. It's going to be pretty much almost identical to the middle pocket. There are some several differences that you'll see, but otherwise it's going to be quite the same. So we're going to click on side pocket chain on the left side right here. It will turn gray as you see. Then go ahead and click on solid mode traditional and then pocketing because it's a pocket. Go to general. We're going to stick with a 3/8 animal. I think that's perfectly fine. Go to strategy, concentric out. We're just gonna leave it like that. Our total depth and starting depth are going to be preset because it already knows what the lowest and highest point of the chain is. That's fine. Our incremental depth was set previously from a template probably. So our depths are all set for us, so we don't have to touch it. Okay. Let's go to roughing. All right, let's set our cutting speed, 12,000 RPM. And then our X feed rate, it was like 0.003, I remember, and then 0.0006. I believe that is it. Yep. Right? Yeah. Okay. Good. Yeah, we're gonna set our step over diameter, step over percentage diameter to be 25, switch conventional to climb milling, but honestly, if you don't do it, not a big deal. And then press OK. And yeah, that's pretty much all you need to do. And you can go ahead and simulate. So, like last time, it is having an issue with the edges. And it's also because it's set to never leave the edge. I mean, go past that edge. And that's something we did by adjusting our open edge to be from false to true. And we're going to go ahead and do that again. So you can stop the simulation, click on side pocket chain, and do the same with our sub-elements. Except this time, we don't want to change all of our sub-elements to be open edge false. We only want to change this line segment to be open, this fillet to be open, and then this line segment to be open. Because if we open up this inner segment, then it's going to cut into the part, and we don't want to do that. We just want to change the parts that are like exposed to the outside area, and we want to change those areas to be, those segments to be open edge true. And you can switch through the different elements, and you'll see that as you switch through them, there's red dots that move around. And right now, mine's is 2:5, the second sub-element out of 5, and that is this line segment right here. You can go ahead and switch it to true. And my third one is this fillet. You can see how there's 2 dots here, and they just move around. You can switch it to true, and just keeps going through the sub-elements. My fourth one is this one. You see how there's a red dot here, and a red dot here. Yeah. And then the other sub-elements you want to keep as open edge false. Yeah, so we're just changing 3 of them because there's 3 segments that are exposed to the outside area. This one, this curve area, and this another one right here. After do that, right click on solid mill pocketing, so we can tell it to rebuild the toolpath. And once we do that, you'll see that it does lines now, which is kind of what we want. And it cuts past the edge. Essentially changing open edge false to true allows it to go past that chain and cut outside of it, which is what we wanted to do. Then you can just simulate. Oh. Remember to click outside. Make sure none of these operations are being highlighted. There it is. We are almost there. This looks pretty good. Okay. And our last thing to do, we have 10 minutes left. We will be doing the slot. It's also a pocket, so nothing too extreme. Something I will note before we start it is that you will have to mess with the open edges because there's this line right here that is exposed to the outside area, and we're going to have to let the end mill move past this line, and then same with the other side. So what you wanted to do is essentially come out, move outside the part, and then go back in. But if you don't adjust the open edge settings, it's only going to stay within this rectangle, and it's going to miss some of the stock, and we don't want it to do that. So you're going to click on, where is it? Slot, this bottom chain. Go and select pocketing. And now we got to decide which tool we want to use. So if we go back to a previous slide, let me find it. Right here. So if you look at these dimensions, you can tell that the width of the slot is 0.35. So the biggest end mill that we can use is a 1/4 inch. Anything bigger will make the slot too big. So we're going to go with a 1/4 inch end mill. So we're going to select our tool, end mill, 1/4. Strategy. These depths are already correct because the total length, the total depth is the bottom right here. Then our starting depth is the top, and incremental depth is already set, which is good. Let's work for us. Then we're going to roughing tab, and then we're going to set our speeds and feeds. So something I want to mention about slotting. Go back to a picture that I had before. Okay, here. So this left picture right here is the diagram of how slotting looks like. Its radial depth of the cut is going to be 100% of the diameter because it goes like it barges straight into the stock. It doesn't even like try to cut on its side. It cuts with its full diameter, and due to this, it puts a lot of stress onto the end mill. But there's really nothing you can do because this is how slotting works. So we cannot change our axial depth of cut, but we can change. No, sorry, we can't change our radial depth of cut, but we can change our axial. So by decreasing the amount that it cuts axially per pass, it can help reduce some of the stress on the end mill. Plus, if we reduce the feed, so it's essentially its translational speed, how fast it moves left, right, up, down. If we decrease that, it cuts less material in the same amount of time. So that will also decrease the amount of stress. So when you're slotting, you want to look at the recommended speeds and feeds and depth of cut, and then go lower. You can leave the speed the same, but you want to decrease your feed if possible. So its XY feed per tooth is 0.002. So maybe we'll set that as 0.001. We'll go half the XY feed rate. So right now it's going 36 inches per minute. How fast is that? That isn't very fast, but it can be slower. Our Z free rate isn't too important because is XY feed rate that really makes it or break it. So we can leave our Z feed rate as 0.0004. If you want, we can also half it too, so 0.0002. That's perfectly fine as well. And then, so our step over percentage of diameter, regardless of what percentage or which step over we put, it's going to automatically set it to 100% because that's how slotting works. And then we press OK. You'll see how it makes these nice rectangles, but it never leaves the part. So before we simulate it, oh, another thing I forgot to do. I wanted to decrease. So if you go back, I wanted to decrease the axial depth of cut. So if you go to strategy, go to incremental depth of cut, we can maybe set it to 0.1, a tenth of an inch per pass instead of 0.25. That will help it a lot. And you'll see that the number of passes significantly increases. It more than doubles, which is perfectly fine. Slotting is very slow, but it's better to go slow than break the tool. So yeah, that is what we have. Before we simulate it, we're gonna adjust the sub-elements. We're gonna go and find which sub-elements we want to change from open edge false to true. So we're gonna we want to change this segment to be true. So we're gonna just go through. So my sub-element 4 out of 5 is this one, it's because you can see there's 2 red dots. And then we're gonna change that to true. And then I'm gonna go to my other segment that I want to open up and wait until I have 2 red dots on it as well. And that is going to be 2 out of 5, and let's change that to true. And those are the only two segments that I want to change from closed to open. So now that I have that done, I'm going to rebuild the toolpath. So to rebuild, you just right click on the operation, go to machining, and then rebuild. And then as you can see, that cutting path is now going past the part, and we want that to happen. That looks good. And go ahead and simulate. Uh-oh, I did it again. That is it. Looks very good. You guys all have this?
Yep.
Yay. That's great. Yeah. That is pretty much what I have for today, although there's one last thing I do want to show you. So to see the order of your operations, so there's this third tab right here next to tools. You can click on it, and it tells you the order. So your your yellow rows tell you which tool you're using, and right below it is the operation. And you can see there you use a 3/8 end mill twice. So if you want to save a couple seconds for tool switches, you can click on one of the 3/8 end mill and then move it. You can drag it to the other one. Make sure you stop your simulation before you do that. It won't let you. Yeah. And right now you can see that these two pocketing operations both use the 3/8 end mill, which is the middle pocket and the side pocket. So it will save some time when it comes to switching tools out, because it takes maybe like 5 to 10 seconds for every tool change when you're machining something. So you can reduce and cut those times down by combining operations together to use the same tools. And you can just run it again. Make sure you don't click on those. And it'll cut this one, and then it'll cut the side one. Wait, it may not let you. Actually, I don't know if I want to do that. Okay, actually, no, it's fine. Yeah, that looks good. And yeah, that is how you use your facing, contouring, and pocketing operations. Okay, so we are done for today. Next week, we are just gonna do the holes. Yeah, we're gonna leave those for next week. Okay, do you guys have any questions? That is it for today.
I'm good, but thank you very much.
Of course. All right, I'm gonna stop the recording.
Thank you.